In the last video, we learned about calculating compound formulas that did not have parentheses. In this video, we are going to learn how to calculate the molar mass of compound formulas with parentheses. In this case, the example is aluminum perchlorate. We know that this first element is aluminum because there's no capital A by itself on the periodic table. So this is not capital A, capital I, this is capital A, lowercase l. The molar mass of aluminum, if we go to our periodic table, is 26.982. Now, the subscript next to the aluminum is 1 because there's nothing there. So we don't have to multiply the 26.982 by anything because a number times 1 is the same number. We move on to the next element. It's a new element, so we add. We go now inside the parentheses. So inside the parentheses, our first element is chlorine, capital C, lowercase l. And we know that it's capital C, lowercase l, and not capital C, capital I, because the perchlorate ion, from our study of polyatomic ions, we know is capital C, lowercase l, not capital C, capital I. So the chlorine has a molar mass of 35.453 on the periodic table. And if we look at our subscript, it's a subscript of 1 inside the parentheses. However, outside the parentheses, there's a subscript of 3. We know in math that when we have parentheses, we multiply. So 1 times 3 will give us 3 chlorines. Therefore, we will multiply the molar mass of the chlorine by the number of chlorines, which is 3. And you can always remember to multiply because when it's the same element, you multiply. When you move on to a different element, that's when you add. Now that we've finished chlorine, we're going to add because we're moving on to a new element. And we know it's a new element because it's a capital letter. In this case, it's a capital O, so it's oxygen. The molar mass for oxygen is 15.999. How many oxygens do we have? Within the parentheses, we have 4. Outside the parentheses, we have 3. Because we multiply when we have parentheses, that's 12. 4 times 3 is 12. And because it's the same element, we're going to multiply the molar mass of the oxygen, 15.999, times the 12. When you put all of these numbers together in your calculator, you get 325.329, and the units, of course, are grams per mole.